This example is very similar to the last. We're dealing with a profit maximization. We have 3 decision alternatives and 2 states of nature, but this time we're given probability information. We are told that state of nature 1, a strong demand for the condo complex, has a probability of 80% or 0.8. We're also told that state of nature 2, the weak demand, has a probability of 20% or 0.2. Or we know that this is just 1 minus the 0.8, the probability of the strong demand. So our job is eventually to determine the expected value of perfect information. Our first task is to calculate the expected value for each decision alternative. So what we do now in this expected value column here, we want to know the demand and associated state of nature multiplied by the probability. So for our first one, decision alternative 1, a small complex, we say equals the payoff of that times the probability for a strong demand plus the payoff for state of nature 2 multiplied by its probability. We can see that our expected value here is 7.8 million. If we go ahead and go back and we lock in our probabilities, then we can just copy our formula down. Then we want to know which of our choices is the best. Well, in this scenario, we want the choice with the highest profit. So again, we'll enter an if statement, and we have equals if the value on my left equals the max of the 3 values, the 3 decision alternative values. Lock those in so we can drag our formula down. Then this is the best scenario. If not, we don't want to see anything. And we can see that the best case will be, or the best outcome will be with decision alternative 3, or condo complex with 90 units. So now we need to move down and we need to look at our estimated opportunity loss. Okay? So here we're going to take, and we have a few more formulas to deal with. So first, we want to take and fill in this state of nature column here. And what we're going to do is we want to subtract the value that we see up in our first table from the maximum value also in that same column. So again, we take and we enter the formula equals the max of these 3 numbers here, lock them in, less the number for that decision alternative and associated state of nature. So we know that 20 is our max. 20 minus 8 gives us 12. Okay, drag that down. We can see our last one here is 0. Well, 20 is our max. 20 minus 20 is going to return a 0. We want to do the same thing for this column. However, we need to change this a bit. We want to be in column C now. We need our second state of nature. Okay. So now our opportunity loss, or what we might miss out on. This is simply equal to state of nature 1 multiplied by the probability that we will have state of nature 1, or a strong demand, plus state of nature 2 multiplied by probability that we will have state of nature 2, or a weak demand. Okay. Drag that down. Now, remember, this is basically the money that we could be missing out on, or what we're looking at potentially missing out on. So we want to miss out on the least amount possible. We want to earn the most money possible. So here we're going to be looking for the least number. So our if statement is going to contain a minimum equals if the value on our left is equal to the minimum, is equal to the minimum of the three. Lock them in. Then this is the best case scenario. If not, we don't want to see anything there. Copy that formula down, and as we can see, we said we wanted the minimum number. 3.2 is the minimum. We can see that this is the best choice. So now we need to see calculate our maximum outcome here. Maximum is simply the maximum that we have in each state of nature. What can our maximum profit be given a specific state of nature? So here we have equals the max of state of nature 1, $20 million. State of nature 2, the max profit of these three, state of nature 2, max payoff, $7 million. Okay, we are going to use these two pieces of information now to calculate our expected value of perfect information. So first we need to calculate the expected value with perfect information. That's denoted by capital E, capital V, small w, capital P, capital I. Expected value with perfect information. This is equal to the max multiplied by, so B22, the 20 million, multiplied by the probability that we will have that, plus the minimum multiplied by its probability, state of nature 2. Okay, so if we had perfect information, if these probabilities were spot on, our expected value with perfect information is $17.4 million. Now our expected value without perfect information is the maximum of these expected values here. So equals the max of these three expected values, or 14.2. So then expected value of perfect information. So if we had perfect information, what could we expect to earn? How much more could we expect it to earn based on having perfect information? So equals with perfect information less imperfect information. So $3.2 million. Now what this $3.2 million tells us is basically we are leaving $3.2 million on the table by not having perfect information. So this may indicate that we want to go ahead and conduct a market survey, see what the demand really looks like it's going to be. $3.2 million is a lot to leave on the table. So again, this example was a profit maximization example from chapter 4 in our text dealing with probabilities.